Hi, I'm Tanya from Biochemical Engineering and Biotechnology Department, and I'm doing my ELL101 project on LED. A light emitting diode, LED, is a semiconductor device that emits light when an electric current flows through it. The symbol of a LED is the standard symbol for a diode with the addition of two small arrows denoting the emission of light. Structure of LED. LED has two terminals, anode and cathode. The longer terminal is the anode and the shorter one is the cathode. It has different lengths for ease of insertion into the breadboard and to indicate which side is positive and which side is negative. In the middle is the diode, which emits light only in forward bias mode. The junction region is enclosed in an epoxy resin of transparent plastic material. It ensures better visibility of light from inside and should be capable of handling high temperatures. As we want most of the light to be emitted from above, the gold film placed at the lowest end of the structure helps to reflect the light that somehow reached the bottom surface of the LED. This resultantly increases the efficiency of the device. Now we move on to the working of LED. As we know, a diode has two parts, a P-type semiconductor where the majority charge carriers are the holes, and an N-type semiconductor where the free electrons are the majority charge carriers. There is a barrier in between known as the depletion region, which does not allow the electrons and the holes to recombine with each other. When P-type side is connected to the positive terminal and N side is connected to the negative terminal of the battery, which is forward bias, the P-type side pushes the hole towards the depletion layer and the N-type side pushes the electron due to repulsion by the negatively charged terminal of the battery, and this causes the electrons to jump from the N-type to the P-type region and combine with the holes. This results in the release of energy in the form of photons. In case of LEDs, the photons have wavelength in visible region, which leads to light of different colors depending on the material. So now, what is the reason for light emission on recombination? So as we know, there are two energy bands in a material, the valence band and the higher energy conduction band. The free electrons are in the conduction band and the holes left by the free electrons are in the valence band. The energy gap between the two bands is the characteristic of a material and is essential in choosing the correct material for making LEDs. So whenever the electrons and the holes recombine, the electrons from the conduction band come to the valence band. That is, in other words, they move from a higher energy level to a lower energy level, and therefore in the process, energy is released in the form of light or photons. The energy of the emitted photon is equal to the band gap and can be given as Planck's constant into speed of light divided by wavelength, that is hc by lambda. Materials used in LED. Generally, the diodes are made up of silicon and germanium as they show less variation with temperature, but in this case, the energy is released in the form of heat. However, in LED, the energy should be released in the form of light. So, for making LEDs, we rather use the compound semiconductors made using elements of group 3 and 5 like gallium phosphide or gallium arsenide. Also, it was observed in the previous slide that the energy is inversely proportional to the wavelength of the light emitted. Thus, by varying the energy gap between the bands, that is, by using different materials, we can observe different colors in LED. Characteristic curve of LED. The first figure shows the characteristic curve of LED. It shows it emits light only in forward bias. LEDs do not operate under reverse bias as the depletion layer is not decreased, making it impossible for the electrons to club with the holes to release energy, and so no current is conducted. The second figure shows the characteristic curve of LEDs with different colors when different materials are used. Another thing to be kept in mind while collecting LED to the power supply is that a resistor is to be placed in series with the whole circuit. This is done so as to secure the circuit from excess current. LEDs are nowadays being used widely, for example in torches, bulbs, automobiles, billboards and signs, TV, etc. The reason being they are advantageous. Some of the advantages of LED are: the size of the LED can be small as they do not have to have a filament inside them, so they can be fit into any device. They are more energy efficient as they have low power consumption. The traditional bulbs take a lot of power as they first convert electricity into heat and then heat into light, so a lot of energy is wasted at heat. They also have longer lifespan and are more cost efficient. They have fast switching. They can be switched on and off instantly. Fast switching is helpful when communicating through light. Thus, LEDs are nowadays being preferred. Thank you.